introduce Prim's algorithm today. Prim's algorithm is a greedy algorithm to find the minimum spanning tree. Let's start from an arbitrary node. Here I will pick the node A, and I keep A in the set of visited nodes. Then I will update A as visited. Now let's check the path connected to the node A. Which path is shorter? There are only two paths, AB or AF. Obviously, the weight 3 is smaller than weight 4. So I will connect the path AF because it is shorter. Now I can put the path name AF here. Then I update the second node I visited, which is F. I keep F in the set. Now let's check the unvisited edges, which is connected to visited nodes AF and the rest of unvisited nodes. Here there are only two paths, AB, EF. Which path is shorter? Yes, EF is shorter because the weight is 3. 3 is smaller than 4. So I will highlight the path between E and F. I will copy the path name EF here. Now let's update the node E as visited, and I keep E in the set. Then let's continue this operation. We look at the unvisited edges, which connected between visited nodes and unvisited nodes. There are only 3 paths here, AB, CE, and EG. So which path is shorter? Yes, 3 is smaller than 4 and 5. So we highlight the path GE. And we copy the path name GE here. Then we mark node G as visited node. We keep it in the set. Now let's repeat this operation again. So we check the unvisited edges, which connected between visited nodes and unvisited nodes. Here, their path AB, CE, and DG. Which path is shorter? 4, 5, 1. Obviously, the weight of 1 is shorter. So we will highlight the path between D and G. Now we will copy the path name DG here, and we mark the node D as visited node and keep it in the set. Let's repeat the operation above. So we check unvisited edges and connected between visited nodes and unvisited nodes. Here, they are paths AB, CE, CD, and BD. This one, 4, 5, 2, 5. Which path is shorter? Obviously, the weight of 2 is shorter. So we will highlight the path CD. And we copy the path name CD here. And we update node C as visited node in the set. Okay, now we only have one node left, which is B. Let's check B and the rest of unvisited edges. Which path is shorter? 3, 4, 5. Yes. The least number is 3, so we'll pick the last path between B and C. We highlight BC, and we copy the path name BC here. Then let's mark the unvisited node B, and we put it in the set. So now we have visited all the nodes, A, B, C, D, E, F, G. And we highlight the path, and we have formed a minimum spanning tree. Can we continue to add any path? We can't. If we add this path, that will be closed circuit. If we add this path, this will be closed circuit. That's what we try to avoid. Since we have found the minimum spanning tree, now what's the total weight of this minimum spanning tree? We only need to add all the path weight together. So it'll be 3 plus 3 plus 3 plus 1 plus 2 plus 3. It'll be 9, 12, 15. That's it. This is Prim's algorithm. See you next week.